In this lab, you will conduct a test to determine the CBR of a subgrade soil sample. The CBR test, or fully, the California Bearing Ratio test, is a penetration test to evaluate the strength of subgrade soils for flexible pavements. The test was developed by the California Division of Highways and will determine one soil property, CBR. CBR is the ratio of the unit force required by a 50mm standard circular plunger to penetrate a soil sample at 1.25 mm per minute compared to the force required to penetrate a standard material at the same rate. This ratio will be expressed as a percentage. The ratio is usually determined for a soil penetration of 2.5 mm. In some cases, the ratio at 5 mm may be used if the ratio at 5 mm is consistently higher than that at 2.5 mm. The test equipment consists of a loading machine to penetrate into the soil specimen at a rate of 1.25 mm per minute, a cylindrical mold with inside diameter of 150 mm with a base plate and collar, a spacer disc with 148 mm diameter, several weights, and compaction hammers. Two CBR tests can be done on the soil you are testing. One is the unsoaked test, which involves preparing the sample and testing it right away. The other test is the soaked test. This requires the sample to first be prepared in the same way as the unsoaked method. It is then immersed in water and left to soak for 4 days with the surcharge weight added to it. After 4 days, it is removed from the water and tested. This test is typically reserved for fine-grained subgrades such as silt and clay, as they are most susceptible to moisture. Both tests will be explored in this lab, starting with the unsoaked method. Before we can test the CBR of the material, we must first prepare the specimen for testing. The material to be tested must be within a specific grain size range. It must pass through a 19mm sieve, but be retained by a 4.75mm sieve. Any material retained by the 19mm sieve should be discarded and replaced with an equal mass of material in the stated range. We will need to ensure we have enough material to fill the mold completely. Next, add water to the sample to bring the sample to a certain water content. In an engineering project, the water content should be the same as that recorded in the filed compaction documents. Mix in the water thoroughly so the sample has a uniform water content throughout. Once the water has been mixed in, you must fill the mold and compact the sample. First, attach the base plate and extension collar to the mold. Next, you must add the material to the mold and compact it. Add it in 5 layers and compact each layer with a predetermined number of blows. In real projects, 3 specimens are prepared. One is compacted using 10 blows per layer, another with 30, and the final with 65. More than 56 blows per layer are required to ensure the sample is densely compacted. After compaction is complete, remove the extension collar and level the material to the top of the mold using a straight edge. Record the weight of the mold and compacted soil. The specimen is now ready to conduct the unsoaked CBR test. If you wish to conduct the soaked CBR test, there are a couple additional steps you must take to prepare the sample. Place the perforated plate on the compacted soil specimen in the mold. Add weights to the top to produce a surcharge equal to the weight of the base material and pavement to the nearest 2.5 kilograms. Immerse the mold assembly and weights in a tank of water and soak it for 4 days. Mount the expansion measuring device on the edge of the mold and record the initial dial gauge reading. Record the readings every day against the time of the reading. A constant water level shall be maintained in the tank throughout the soaking period. At the end of the soaking period, record the final reading of the dial gauge and take the mold out of the water tank. Finally, remove the free water collected in the mold and allow the specimen to drain for 15 minutes. Remove the perforated plate. Weigh the soaked sample and record the weight. The specimen is now ready for the CBR test. Regardless of whether you are conducting a CBR test on a soaked or unsoaked sample, the test process is the same. First, place the mold assembly containing the test specimen on the lower plate of the penetration testing machine. Apply the surcharge weight by placing the slotted weights on top of the sample. Next, seat the penetration piston at the center of the specimen with the smallest possible load, in no case above 44 newtons, or 10 pounds, so that full contact of the piston on the sample is established. Make sure the piston is not seated on the slotted weights. Now set the load and deformation gauges to read 0. Apply the load on the piston so that the penetration rate is about 1.25 mm per minute. Record the load readings every half millimeter of penetration until 2.5 mm, then record at 4, 5, 7.5, 10, and 12.5 millimeters. Finally, raise the plunger and detach the mold from the loading equipment. Weigh an empty sample cup. Take about 20 to 50 grams of soil from the top 30 millimeters of the sample, place it in the sample cup, and weigh it again. Dry the sample in the drying oven, and weigh one final time when dried to determine the moisture content of the sample. After the test is done, you may take the data you gathered and process it to determine the CBR of the material you tested.